use this big blue button here, no problem at all. I use in the summer. I taught one course in the summer to try to see if it's work, and I figure out it's working, and now surprising me. But I have to look for other ways also. If in case of crash, then we have other things to do. Okay, guys. I think I introduced myself last time here, and even I don't know if it's recorded or not. But since you are here, most of you here, they are here today. My name is Mohammed Tawheed. I'm a professor at Math and Stat department here. I'm here at TRU for last 20 years, and I'm applied mathematician. I teach engineering guys, business, mathematics, and modeling simulations. I'm here, my position at TRU is research position, so I do a lot of research and less teaching. So like all this semester, I'm teaching only one course. That is the course that for you guys here, this Math 1300. So that is very much. So I put here the outline. Please go ahead and read the outline. If you have any concern, just email me. Your class here is very big class. Since I came here at TRU, I never taught this number of students. We have 70 students, or like 69 or 70 students. That's for me it's a huge number. But we imagine here of those 70 here, everybody email me. Then I'm not going to do anything in my work because I have to reply. But it's if the question repeated from most of you here, then I reply to all of you here, and I mention I try to answer the question for all of you here, so that instead of individuals. So excuse me here if I do that, but because as I said here, you have big class 70 students, and that is big software engineering and plus transfer engineering. So we combine both of you here in one class. So what we're going to do here, guys, let us start here. I think we have what is going on here. We have 3 classes, like 15 minutes class, and we have seminar time. So they divide all of you here to two seminar. So most of the time I will give the seminar time here. So I give you for your designated seminar, I will give what's called here quiz. And I will, so that is every week I give a quiz, and this quiz, so you will have assignment and quiz. The quiz that you are going to take here it will be weekly, the material that I cover during the week. So for example, here, if you have, if you have Wednesdays, your Wednesday here is your seminar time. Then any class, I cover one class before, like, I don't know if you have Tuesday. If you have Tuesday class, then I will not cover the class that one day before. Like if you have your seminar Wednesday, that is your quiz will be there. So if I have Tuesday class, I don't know if you have a Tuesday, but I forget your schedule here. If you have Tuesday class, then the material that I cover on Tuesday will not be included on your quiz because I have to give you time. But if you have Monday class, it's okay because I give you 1 day gap so that you can study. So that's very much the final exam here. It's only one. Usually, because you have huge number, then I will divide all of you here to maybe 4 group or 5 group, depend on how many. So we try. It's very, very important, guys. Here you are study your career as engineer, as I mentioned last time. So it's very good to start with honesty. You start with no cheating, no try to be yourself, because that is your level here. Whatever you get, that is the one you are going to get the job according to your knowledge and all of this, and also the reputation of TRU. So here we have it's called academic integrity here. So we're assuming you are. I mentioned that in my outline. I mentioned also the seminar. So I'm assuming here you do that your assignment or your quiz by yourself. Nobody. You cannot take the questions and you put it in Google to get the solution, or you subscribe on some website where you provide the solution and you will get it. In the quiz, I will be a specific time. Like if I give you the seminar time, your seminar time, where that is the time you can where you can If I give you seminar time, that is the one that is I'll put the time very specific. I mentioned here you have to load app here. So I bought the outline. I bought the outline on Moodle there in Moodle. It's not in the class here. It's supposed today I'm going to teach. Because last time I spoke about this outline, but you can go ahead and read this outline after in the evening or today. Just read it when you have the time, and just if you have, yes, it's in Moodle. So if you have any questions related to this outline, please you can come back and ask or email me, or when I start next class in the beginning of my class, you can always ask what you have. I work in administration at TLU here, so I have one meeting. I will tell you if I have a meeting conflict with the class, I will let you in advance. And what I'm going to do, I will record the lectures, and then I will put it and I give you the link for this. If I need to, I don't need to be in the class, or I have conflict a meeting or something. Then I will let you know in advance. It's not just 1 day or 2 days. I will tell you the plan in advance. Okay, guys, on Tuesday, for example, here I have a meeting, or I have to be in Vancouver or something. But here is the link of the class, of the lecture here, of the whatever I recorded, and then I put it there so that you are not losing your class, which is 50 minutes. That is very much the plan here, guys, for you. But I think you go ahead and look for the outline for what I have written there. I'm going to follow my mass lab here. That is the one you have to buy British access to that. And you have the book. You can load it from there as PDF. So my mass lab here, that is the one I give. I'm going to give the assignment. You can access, and then you can try the assignment. I'm good. You have one. I will give the plan here one over the weekend. Usually I give one assignment. Also in the seminar time, you have one quiz. That is the material that I cover during the week. And I will tell you, okay, here the quiz will be covered, which section I will let you know. But I tell you here that the material that I cover one class before, like if I cover until Monday, if you have, then is okay. That is the material. So whatever I give you up to Monday, that it will be included. But then that's quiz number one. Then I go for quiz number two, and so on and so forth. But what is good here? We see how many quiz you write at the end. Maybe I drop one, depending on how many quiz you write. So usually I drop the lowest mark that you get in one of the quizzes, depending on how many quiz you write for the whole semester and how many assignments. But I put the quiz and the assignment 35%. I put some test here. It will be 35, and the final 30%. So what is going on? 30%. So what is going on here? I try to look for your mark for the test here, the midterm, and for the quiz and the assignment. If it's really too high, then we look to the final exam and we'll see. Okay, so let us do that one by one. All right, guys, where do you find PDF for a book on Mass Lab? So here you have to purchase. There is a barcode you have to access. So you have. I bought the link here. If you look to Moodle, that when the first thing I posted, how to access to my Mass Lab. So you have to buy. Unfortunately, you have to pay some. I forget how much, but you have to either you can purchase this from bookstore or from their website. That is where you can buy the access to. It's called My Mass Lab, and that is when you buy this, they give you access to get in, and when you get in, then you will see the book also as a PDF file. You can access to that. Okay. If suppose that looking for something, we can only see MS document. Okay. So now you are not seeing my file linear equation here. So did you see, guys, what I have here? Let me start my class here, or you have a question here related to the outline here. So what I'm going to do here is let me start the class, and then what you do, you go ahead and read the outline, and then when I start next time in the class, if you have concern, you can either email me before or waiting in the time of the class, and you can ask me here in the beginning or at the end of the class. Okay. So let us start here, guys. What is system of linear equation? System of linear equation, maybe some of you have seen that on high school. But what is linear equation? What is linear equation means? So here, if you look to this file here, guys, when you have equal signs, that's called the equation. So when you have equal sign, that is, we call it equation. And now we'll call it linear. Why we call it linear here? Because if I look to the variable here that I have in the beginning here, maybe I give you here, I think I have here example, like for example here, if you have 3x plus 2y equals say 1, something like this. So is this one here linear equation? Yes. How did you know it's a linear equation? Because we have equal sign. So when you have equal signs means you have equation. Why? How many variable you have, or how many unknowns you have? I have two unknowns or two variable x and y. If I look to the highest power for x and y is 1. The highest power for x is 1. The highest power for y is 1. So because your unknowns or your variable here, the highest power is 1, we call it linear. We call it linear. So that is called linear equation, guys. That is the example here, linear equation. As you can see, the number in front, this unknown or your variable, just real numbers. So you have 3 here, that's a real number. 2 here is a real number. When I look to the right-hand side, that's called constant term. So or we call it the coefficient here, the coefficient of your variable x and y, that is constant here. So that is, we call it linear equation. So here, when I look for this one here, that is more very general here. So if that is called here two variable here. I have two variable, which means when I have two variable means I work in 2 dimension, x and y. So now if I go for 3, maybe I go for, so here negative x plus y plus z equals say 2. So if I have negative x plus y plus z, if I look for this equation here, what kind of equation you have here? Is this one equation? Yes, it's because you have equal sign. Equal sign means you have equation. All right. So how did you know it's a linear? Now I look for my unknowns. What is your variable here? Your unknowns. Oh, you have x, I have y, I have z. So you have 3 unknown or 3 variable. If I look to the highest power for all variable or your unknowns, which is x, y, z, you'll find the highest power here is 1, 1, 1. So now the number in front here, x, you have negative 1. That's the coefficient here, negative 1. The coefficient of x, negative 1. The coefficient of y, 1. The coefficient of z, 1. And here you have 2, which is a constant term. So now, is this one linear? Yes, it's a linear equation. You have how many unknown? You have 3 unknown x, y, and that is 3 dimension. So that is, you have your x, and that is your y, and that is your z. Or so you have 3 dimension for this equation, but it's still linear equation. So now, in general here, if I look to what I wrote here, linear equation, and you have any variable or n unknowns, you have x1, x2, up to xn. All this, we call it unknown or variables. And that is equation. We can write it. If you write it a1, x1, a2, x2, plus keep continue like this, a sub n, x sub n equal b. What is b? B here is a constant term, just a number, real numbers. So a1, a2, an, all of them, and b, we call it here constant scalar. What is constant scalar? Scalar here means real numbers, just the numbers. So if you have, how many variables you have here? We have n variables. Like the dimension here, we call it n dimension because how many unknown you have? You have n of them. So since you have n variable, x1 up to x sub n, then if I look to the highest power I have, you find for all of them is 1, then that is linear. Yes, we call it linear equation. We have linear equation because you have equal sign, and all my unknowns or your variables, the highest power is 1. Now, some people can ask a question. What about if you have one of the unknowns, not 1? So, for example, here you have x squared plus y equal 1. So here, how many unknown you have here? xy. What is the highest power for all my unknowns? Your y is 1. but your x is not 1, it's 2. So because of that, this one is not linear equation. That is equation because you have equal signs, but that is not linear equation. We call it nonlinear. Become nonlinear. Why become nonlinear? Because one of the unknowns become here you have what's called here square. So we call it quadratic equation, right? If you want, you can call it quadratic equation. Equation because you have equal sign, and the highest power here is 2. We call it quadratic equation. Now, what about if you have something like okay? If you have something like maybe I'll go for just I have some example here. So here, if I look to this example here, then I can the equation. If you have ax plus by equals c, what is this equation? If you have seen that in high school, we call it equation of a line. Equation of a line. So that is linear equation, yes, because your what is your a constant number, real numbers, b real number, c also real number. And if I look to the highest power for x and y, just 1. So that is linear equation. So this one here, it's a linear equation. The second example, number 2 here, if you have ax by plus c, that's c, z equal d. What is d? A real number. A, b, c, d, all of them real numbers. But what is my unknown? X, y, z. If I look to the highest power for this, you figure out the highest power for this is 1. Because of that, it's nonlinear. Because of that, we call it linear equation. Equation because you have equal signs, and that is, we call it linear equation. So here, they ask you here to figure out which equation here linear, which equation is not linear. So now, what is your E, guys? Your E here is, it's a number 2.7. When you have your technology, you'll see E 2.7. What is your by? By here also, when I use your technology, you'll see that's 3.14. Right? What is the third root here of 5? If I use technology for this, you'll find it's real number, just real numbers, right? Real numbers, which means a number. So now when I look to this one, do you have equation? Yes. Why? Because you have equal sign. What do you have in the right hand side? 0. Is 0 here real number? Yes. So you have 0 real numbers. When I look to that, your unknown, which is x, y, z, the highest power for x, y, z is 1. So, and the coefficient here, the number in front, this variable, which is x, y, z, just the numbers, e 2.7 by 3.14, third root of 5 is a real number. So because of that, this one, yes, it's linear. So this one, so this one here, it's a linear equation. I'm just trying to check, which is yes, it's a linear equation. When I look for the second example here, guys, that is equation, yes, it's equation. But what is my unknown? X, Y, Z. So X, Y, Z, but the highest power for X and Y and Z is not 1 at all. Is not the highest power is not 1. So this one here is not linear. So this one here is not linear. And here are 2, right? So it's not, what is not linear here? It's enough or sufficient here to have one of these unknown. The highest power is not 1. If one of these unknown, just X. So if you have like X squared plus Y plus Z equal 1 like this, you look to your unknown, you're the highest power for Y 1, Z 1, but X here is 2. So because of one of the unknown is not 1, that's enough to say it's not linear. So this one, non-linear equation, right? So now when I look for the second example also, sine pi over 4 here, if you try to use a number, you'll find it's a number also when I use technology. So what is my unknown here? You have X, Y, Z. X, Y, Z. So that's my unknowns. What is the highest power here? I have -1. When you have -1, that is enough to quit. You tell me, oh, it's not linear. Because it's required for us, the highest power for all unknowns must be 1. All right, guys. So now I look for the second example for this one here. If you have X, Y, X multiplied by Y plus Z. You see here, it's because X multiplied by Y, this one is going to give you here a nonlinear equation. Why? Because the highest power for X is what? Is 1. What is the highest power for Y? Is 1. It's like you have linear term multiplied by another linear term, you are going to get quadratic term. If you have a linear, what is X to the power 1 is what? Is linear term. So here, you see, when you have X squared, how did you get X squared? X, it's like this. It's like this. X to the power 1 multiplied by X to the power 1. X to the power 1 here, we call it linear term, guys. And here, also linear term. So when you have a linear term multiplied by linear term, then what did you get? You get quadratic term. So what did you get? You get non-linear term. Quadratic term mean it's a non-linear term. So here x to the power 1, y to the multiply by. So here when you have x to the power multiply by y, then that is enough. You quit to tell me it's not linear. It's a non-linear equation, because here you have linear term multiplied by another linear term. Then you get it's like quadratic term or non-linear term. All right, guys. So that is example. So now, what is our goal for this chapter here? Our goal here is to know what do you mean system of linear equation. System of linear equation. System means you have more than one equation. You have more than one equation. So what I try to here, I try to give what is system here. So if you have, for example, here, now I look for what is system here, guys. System here, system of linear equation. I just try to explain this stuff here. It's elementary stuff, but it's okay. So system of linear equation here means you have more than one equation. How many of them? You could have here we are going to learn in this chapter 2 by 2, 3 by 3, 2 equation and 2 unknowns. Like the number you have when you say system of linear equation, when you have equation here, you have S here, means you have more than one equation, more than one linear equation. So you could have 2x plus y equals, say, 1. Is that linear equation? Yes, I call it equation number 1. So here, your unknown x, y, the highest power is 1. And the number in front, x and y, here, the coefficient here is real numbers. And we'll call it constant. And here also on the right-hand side, you have a constant. So now if I take another equation here, x plus y equals, say, 2. Is this equation 2? Yes. So what do you have here, guys? You have x and y. That is your unknown, the highest power 1, 1. And because of that, what did you get? The first equation is linear. That is linear equation. When I look for the second equation, also it's linear. So what is our goal? I'm going to combine 1 and 2. I look for not only for 1 separate or 2 separate. I'm looking for the whole system. What is system? More than one equation. Equation 1 and equation 2. So now when I look for equation 1 and 2, now we call it system. So, but why system? But because each equation, 1 and 2, linear, each one of them is linear, then we call the whole system is linear equation. The whole system is linear equation. So now, if it turns out you have one equation is linear, but the second equation is not linear. So if I repeat the same, so this one here, it's a system of linear equation. So now, if I go for, say, I repeat the same story. So you have negative x plus y equal 2, but the other one, x squared plus 2y equals, say, 1. So this one linear equation, that is example number 2 here. Example 2 here, so that you will not confuse. That is example 1. Example 1 here, that is linear system. That is our linear system. What do you mean linear system? It means you have more than one equation, and each equation must be linear. Must be linear. All right? We call it linear system. So how many equations you could have? You could have 100, 200, or 300. When you go, especially our engineering guys, if so, some of you here, if you continue computer engineering or electrical engineering, you will see this one here. We call it, it's a system there, but we call it large scale. What do you mean? Large scale of system of linear equation. How many? We could have 200 unknowns and 200 equation. And whatever we have learned or are going to learn this chapter, you could extend it to the same approach we are going to solve by 2 by 2 or 3 by 3. Because we are doing that by hand, but usually we use software programming to solve this large system of linear equations, 200 by 200. I use MATLAB software, and so what I'm going to do here, I could have, if I have time for this course, then I will show you here how to use MATLAB. I'm using, we have at TRU here the license. We could use, I could show you here how to use MATLAB to solve the technique that we are going to learn. I can show you how to use it to solve system, large scale, big one, and how to try to make it easy for ours. But it's very important here. We are not really relying on technology, but we have to learn, because when we write a code, we learn the technique, and then based on our understanding here, we write our code, right? So it is we cannot rely blindly on technology. We have some expectation. So now, when I look for example number 2, guys, here, if I look at the first equation here, what did you get for the first equation? I got equation 1 is linear. But when I look for equation 2 here, guys, what did you get? Equation 2 here is not linear. So this one is not linear. So because of that, the system, the whole system become non-linear system. So the system now become non-linear system. So that is not linear anymore. So the whole system become non-linear system. So what is going on here? Non-linear system, and the technique to solve linear system very different from solving non-linear system. So in mathematics, when you have to learn how to solve linear system, that is a specific technique. And also when you go for non-linear system, we have to use a different technique, right? And of course, real life situation it's non-linear and is not nice, smooth. When you deal with applications and all of this, you'll see it's quite difficult and tough when you have a model or when you have to do simulation. It's not always linear. Here is represents simplicity. Refer to simplicity for the system. Refer to anything when say linear means it's very nice and easy to solve. When you go for nonlinear, then you will have some quite difficulty. But we have to learn both here, right? So now that is now we'll conclude. You see, guys, I'm just focus here on in my. I hope it's. I'm not looking for if you have a question or anything here, but if you so PDF big screen so that you can exactly where you are, where you're talking. So is that everyone see what I'm doing here, guys? Because or I'm just talking here to myself here. Do you hear? You follow, guys? All right. Thank you. So then is great. So if you have a question, always you can make it unmute and just say I have a question. Then I can. If I need to slow down, also you have to tell me also slow down. But here I'm putting my hand on my heart here about crashing this big blue button here. So I would like to finish. I'm hoping to finish the class completely. So that's the reason here I try to catch, but I think what we'll do here, it's always first week here. It's quite unorganized. I email this IT service and they say they are working on this. But here we have to look for other ways to teach also our not rely on the big blue button here. Okay, guys. So now I'm going to define here what is so-called solution of linear equation. Solution of linear equation. You follow, guys. Recall here. So that is kind of definition of a solution of linear equation. Here I try to make any equation, like how many variables you have, any variables. So we call it vector. That is vector here, S1, S2, Sn, whose components satisfy the equation. When x1 equal s1, I'm going to let me explain this. S1 equal s1, x2 equal s2. So here, what is s1, s2, sn? That is a number, just real numbers. So if you have these real numbers, if I put it in this equation, what do you have? You have left-hand side here. That's the left-hand side. If I put s1, replace x1 by s1, x2 here by s2, then what did you get? You get b. For example, here, guys, try to make it. So if I give you this equation, for example, 3x plus 2 equals 0, right? So now, if I need to solve this for x, first of all, how did you know this one linear equation? Yes. Then what you'll do here, you can ask me, where is y? Here you have only x. The y here is this equation. I could write it like this: 3x plus 0y plus 2 equals 0. Is this one the same? Yes. Which means if you don't have y here, means the coefficient of y is 0. The 0 here is the real number, but 0 multiplied by any number, what did you get? You get 0. So that is the reason there is no y, which means the number in front y is 0. All right, guys? So now, if I ask you to solve this one, how you solve this one from high school? Okay, you take 2 the other side. So you have 3x equal minus 2, right? Then I need to solve that for x. When I solve that for x means, what is x? X equal what? So the number in front of x must be 1, which means I have to divide by 3. So that is your x. So this one here, we call it solution. Solution means your x equal this number here. If you try to check your solution correct or incorrect, right? So what you are going to do, you are going to take x here. What do you have the equation here? The equation here, guys, 3x plus 2 equal 0. So you try to make sure the solution here, you have to verify. So here is your x. So I'm going to replace x by negative 2/3. So in this case, what did you get? If I replace x by negative 2/3 plus 2 here, so what did you get? So if I simplify this, 3 cancel with 3. So what did you get from here? Negative 2 plus 2, which is just 0. So what did you get? You get the right-hand side. If you get the right-hand side in my equation, means, yes, this solution is true. That is real. That is correct. The solution here I got is correct. Then what is your y? So your y here is not known. Your y here is not known. But here, if the coefficient of y is 0, does not mean y here could be 0. Your y here could be non-zero too, because 0 multiplied by any number, what did you get? You get 0, right? So here y, it could be, we call it free variable. What do you mean free variable? It could be any real number you wish. It could be any real number you wish. But anyway, let us go one by one here instead of going deep here or confuse you. Here, if you have 3x plus 2 equals 0, that is linear equation, because if you consider it's only one unknown, which is your x, the highest power for x is 1. And then you have x is about 1. Then when I solve this, so that is linear equation, I figure out, so that is x equal negative 2/3, that is my S1. S1, so your S1 here is negative 2/3. All right, we can extend this to for here. I have some example here. I think maybe I try to follow the notes here, but it's okay here. So here, guys, what you have is 1 minus 1 and 1. We call it vector. So here, what is your solution, guys? Your solution x1, x2, x3. So I need to get the value. When I have equation like this, we call it linear equation because you have equation. Your unknown x1, x2, x3. What is the highest power for x1, x2, x3? Is 1 for all of them. All of them is 1. So that is linear equation. Here is the solution. They tell you here, okay, the solution 1 minus 1 and 1. Is that one solution of this equation? Let us try. How we try? Try to verify it's a solution or not. So your x1 is given here equal 1. Your x2 equal minus 1. Your x3 equal 1. Right? Your x3 equal 1. So now I go this value here, guys, and I'm going to put it here. Try to see, did you get on the right-hand side? What do you have on the right-hand side? Just 1. So I replace x1 by 1 plus x2. What is x2? Minus 1. Always you have negative number put it between bracket. Plus x3. What is x3? Is 1. I simplify this. Negative 1 cancel with 1. So what did you get? I get 1. What is 1 here? That is my right-hand side. So yes, that is the solution. That is one solution. So that is your x1 is given, x2, x3. Our goal, guys, we are going to figure out the solution, how to get the solution. Our goal from this, it's one by one, to get the solution. All right, guys. So here, another example here, try to show is this one here one of the solution? Yes. So what is one of the solution here, guys? You have x1 here. If I look at this equation here, you have two unknowns, x1 and x2. x1, the highest power for x1 and x2, all of them 1. The highest power is 1. So because of that, it's a linear equation. Here is a solution. They tell you x1 equal minus 1, x2 equal 2. So that always it's like this. When you have it's always that is the solution. You make it as a vector. Here we call it vector. We stuck them like x1 and x2 like this. But you can write it like this or like this one here is either or the same. All right. So you have x1 equal negative 1, x2 equal 2. If I put that in my equation here, guys, 2, what is x1? x1 is negative 1. What is x2? x2 is 2. So if I simplify this, you must get the right-hand side. That's called right-hand side. What is my right-hand side? Right-hand side, that is my 0 here. The left-hand side, which is 2x, that is called left-hand side. So if I replace x1 by negative 1, x2 by 2, I must simplify this. What did you get? Negative 2 plus 2. If I simplify this, you get 0. Then I look to 0 here. Is that exactly the right hand side? Yes. Then yes, it's a solution. Yes, is this one of the solution? Yes, it's one of the solution. All right. So that is one of the solution. I'm going to come to this one here in more details here. I'm just today here. It's kind of we try to be slow here. People coming from summer, and so it's quite slow the first week and all of this, but it's okay, guys. We'll do it. I think this course you will like it. I'm very sure you like it, and I will do my best here to make it clear as much as I can. All right, guys. So now, what is the system here? We define here a system of linear equation. Definition here, or kind of terminology here. A system of linear equation is a finite set of linear equation. You have finite number of equation. As example, I show up here. You have equation 1 and 2. If you look at the example I show you here, where is the equation here? For the example number 1, that's called finite. Finite means it's finite. You can count them. Oh, here 1, 2, 1, 2. That's finite. Yes, we call it finite number of set of solution. So equation here. So equation 1, equation 2. You could equation 3, equation 100, equation 200. That's called finite. If you can count them, or 1, 2, 3, 4, up to 100, 200, 300, we call it finite. We call it finite. But you cannot have up to infinity. No, you cannot have infinity equation. But what you should have, you have finite system of linear equation, while referring here to finite set. Set means a collection of linear equation. So each with the same variables. Okay, so each equation, if you look to up equation 1 and 2, your variable x and y, your unknowns x and y. So that is the definition of system of linear equation. A solution of a system of linear equation is a vector. Vector here, as I mentioned here, when you stack them like this, x1, x2, you keep continuing up to xn, that is called vector here, guys. When I stack them like this, we call it vector. That is simultaneously here solution for each equation in the system. All right. So here the solution here, as I show you in the example there, x1 and x2, this one that's called the vector here, minus 1 and 2. If you put it in the system, you must have the right hand side. But not only for one equation. If you have two equations, I'm going to show you two equations. When I look for the solution must satisfy all equation 1, equation 2, depending on how many equations you have on the system. If you have a system of 100 equations, then how many unknowns you have? You have 100 unknowns. And then when you solve these 100 unknowns, then you are getting x1 equal real numbers, whatever number. So you have 100 value, which is your unknowns. And then you stack them as one vector. First entry x1, x2 up to x100, and then this solution, or that is a number, they must satisfy all equation, guys. Here one example here, instead of talking, and you will have kind of what this guy talking about. Here, look what you have x plus y equals 0. The second equation, 2x plus y equals 3, right? So when I look to this equation, is that a system of linear equation? Yes. Right here, they tell you the following system of linear equation has which means is given to you the system of linear. But if I ask you to solve the following, and then you have to check, this is one system of linear equation. I look to equation 1. Equation 1, you have equal signs. If you have equal sign, then it's equation. Now, what is my unknown? X and y. The highest power for x and y is 1, so that is linear equation. Equation number 1 is linear. I look for the second equation. What is the second equation? The second equation, you have equal sign also, equal sign. Why I give attention equal sign? Because you may have not equal signs. You have inequality. You could have x plus y less than or equal, or greater than or equal, or less than or greater than. If you have one of these here, that is not equation anymore. We call it inequality. And that is the solution to solve inequality is very different from equation. So equation here stands for equal sign. If you have less than or equal, greater than or less than or greater than, we call it inequality, and the situation here will be very different when I solve. Okay, guys? Or I take this one here out. So now when I look to the second equation, guys, equation 2, also linear. So now my system here, I have a system because you have more than one equation, and all of them linear. All of them, one linear, two linear. If it turn out one of them not linear, then the whole system become non-linear. The whole system become non-linear. So now 1 and 2 linear, and then I go ahead and solve how to solve. That is two equation. I should write two equation. How many equation you have? Two equation. How many unknown you have? Two unknowns. Two unknowns. So here, guys, when you have two unknowns or two variables, but you always write unknowns. Unknowns, and our goal to get these unknowns. What is your unknown? X and Y. So now if I write this vector X and Y, I could write it like this. X and Y. I need to get X and Y. That is my solution. What is the value X? X equal what? And your Y equal what? That is your goal. How to solve this one here? You have, if you recall that, some of you have seen that maybe in high school, you have many ways to solve this one. One way we call it elimination. Another way we call it substitution. Third way you could do that by graph. What do you mean by graph? Let me show you. I'm just here kind of review the first week here, but the time is really fly. So the first one, using elimination, let me solve that. I need to get X. What is my goal? I get solve. Solve means what is your value X? What is your value Y? But if you this value, in order to call it solution, if I put it in equation 1, you must get the right-hand side, which is 0. If I put that in equation 2, you get 3. If it turn out you get value for X and Y, if I put it in equation 1, you get the right-hand side, which is 0. But if I put it in equation 2, you get something different from 3, from the right-hand side, then that is not a solution. Solution means if I put it in all my equation, your equation become valid, become true. Means, what do you mean valid or true? It means you get the right-hand side. It means your right-hand side, you must get it. So now, how to use that? It's called elimination. So let me use it's called elimination here, guys. Elimination technique. What is elimination? Try to get rid of X or Y. Try to get rid of X or Y, one of them. So here, when I look to the first equation, X plus Y. The second equation, 2X plus Y. So now, what happens if I take equation 2 minus equation 1? Equation 2 minus equation 1, what did you get? So here, 2x in equation 2, 2x minus x. 2x minus x. Y minus y, what did you get? Y minus y cancel. Equal 3 minus 0. And here, y minus y, you get 0, right? So if I simplify this, guys, what did you get? You get here 2x minus x, you get x equal 3. So that is your x. Now I need to get y. How to get y? You can go back to equation either 1 or 2, one of them. Replace x by the value that you got, which is 3. Then you are able to get y. It's easy to get from equation 1. Y equation 1, your equation 1, x plus y equals 0, means your x equal minus y. Your x equal minus, take y to the other, so x minus y. What is your x? 3. What is I need to get y. So which means you have to multiply both sides by minus 3. So here I got the solution here, guys. So what is the solution here? Your x is 3, and here is the solution. Your x equal 3, and what is your y? Minus 3. So what did you get here, guys? I could write it as a vector. There is your x, and there is your y, which is your x equal 3. What is your y? Minus 3. How did you know is this one here? If you want, that's my solution here. But in order to check, before I try to say correct here or incorrect, you can go back to your equation, both equation 1 and 2, and replace x by 3 and replace y by minus 3. And see, you must get 0 on the right-hand side in the equation 1, 0, and you must get 3 in the second equation. So now, what is your x? 3. What is your y? Minus 3. So 3 minus 3 gets 0. That's correct. Second equation, 2 multiplied by x. What is x? 3. 2 multiplied by 3, you get 6. Plus y. So you have 6 plus y. What is your y? Minus 3. So 6 minus 3 gets 3. So that is your solution here is correct. Your solution here is correct. Okay, guys? So that is called elimination here, guys. This one here, we call it elimination. So now, maybe I solved the second one using substitution. But you can always, it's kind of review here. So what I'm going to do here, guys, is that clear, guys, so far? I try to see if some people, I'm streaming for, you can do the same. Okay, all right, guys. All right. So now that's called elimination, guys. Now, if I try to use substitutions, substitution here is what you do here. You try solve. Let me recall that for you. Here was how to solve substitution for this example here, or maybe I go for the second example, but it's okay. So for this one here, if I try to use substitution for the same example, because it's very simple here. So what we have, you have x plus y. Let me write it here. X plus y equals 0, and the second one 2x plus y equal 3. Right. So I'm going to use here. It's called here substitution, guys. How to use substitution? So substitution here, guys. You try to look for. Let me do it two ways here. We call it substitution. One way, you can go ahead and equation 1 and 2. Go ahead and solve one of the equation for one. How many unknowns you have? Two unknowns, x and y. So what I'm going to do, I'm going to solve in one unknown. I write x in term of y, or I write y in term of x. It's one of them. But if you decide to write x in term of y in one equation, you must write in equation 2, you write x also in term of y. So here, when I look for equation 1, it's easy to write x in terms of y or y in terms of x. But when I look for equation 2, which one is easy to write x in terms of y or y in terms of x? So this one, it's easy to solve for y, and this one also solve for y, because if you solve for y, you can take this term to the other side. So it turned out, when I look to the whole equation 1 and 2, I figure out they are easy to solve for y, not for x, because here for the second equation, if I solve that for x, I have to divide by 2. Then you get fraction, and you don't like to deal with fraction. So here I look for equation 1, it's easy to solve for y. Likewise, equation 2, I can solve that for y. So when equation 1, if I solve that for y, so what did you get? You get negative x. We call this equation number 3, right? And then equation 2 here, I need to solve that for y. If I solve that for y, what did you get? You get 3 minus 2x. I call this equation number 4. So now, if I look to this equation, that's called substitution here. You have y equal negative x. So that is y, and that is also y, the same y. So because I'm looking for solution satisfy equation 1 and 2, then because it's the same y, I equate equation 3 and y. So equation 3 here, guys, equation 3 equal equation 4, both of them, they are equal y. Both of them equal y. So what did you get? Equation 3, you get negative x equal 3 minus 2x. Minus x, and here 3 minus 2x. So what did you get here, guys? I got now one equation in one unknown, which is easy to solve for x. If you have one equation, guys, in one unknown, it's very easy to solve for this unknown. So here, how to solve this? You just to collect all x in one side and collect all. So here you have negative x, and here you have negative 2x. So I'm going to collect here what you have, that's called constant term. 3 here, we call it constant term. So what I'm going to do, I collect all my unknowns in one side. So what you have in the left-hand side, negative x. So here what you have, negative 2x. I take that to the left, become plus 2x. And what do you have in the right? 3. So I'm collecting all the term has unknowns here, x in one side, the constant term in the other side. So if I simplify that, negative x plus 2x, what did you get? Just x. What did you get? X equal 3. So now you can go back to equation 1 or 2 or 3 or 4. Which one is easy? Number 3. If I look to number 3 here, guys, you have y equal negative x. So now, what is your y equal negative x? Y equal negative x. That is from equation number 3. Then what is your y equal negative 3? And that is called substitution, guys. That is called substitution. So you can solve. So if you have two equations and two unknowns, you can solve in one unknown. Like you write one unknown in terms of the other ones. But if you do that in one equation, you must do the same exactly like number 2. That's called, they call it some, in the textbook here or other textbook, we call it substitution. But also we have another way we call it substitution. Maybe I will stop here, and then maybe I start next time. What is another way for a substitution? All right, guys. So what I'm going to do here is maybe I will stop recording here, so there is a stop here, and I'm just recording for using several technique here to record my class today, so that nobody will miss the whole thing. You follow, guys? So I think I'm recording here. I'm spending very much time to be ready for this teaching here. I'm talking about from yesterday. Last time when it's a crash, I felt very bad because I said, okay, guys, it's your time, and I feel I would like to give this one. All right, guys. Do you have any question or any concern about this one so far? I know this stuff is easy for you guys. All right. No. All right. Thank you. So, all right. So, guys, you have a good evening here. So, what I'm going to do here, go ahead, please read what's called here. Read the outline. And if you have a question or concern, and be patient with me here, because I'm very new also for my math lab here. I never use that, because when I teach face-to-face, I believe face-to-face here, mathematics should be teach face-to-face, because you learn more and better, and also I will know you are writing the exam, right? And so here I'm using my math lab, the first time for me, but you will see you will learn a lot of stuff, but the problem about time, and you are taking maybe 6 courses or something for engineering here, it will be very hard for you, but you would like to learn it, just do it, right? And I try to be with you here. All right, thank you. You have a good evening, guys.
Mohammed?
Yes.
Hello? Oh, hi. Yes, just a question. Is there anything you want us to do for next class?
If you buy what's called Bridges, I bought the notes, right? I bought the notes for the one that my notes that I'm going to solve. So you go ahead and just try read it before you come. And also, if you purchase what's called access to my math lab here, and then you can see the textbook there, section by section. So you can read. Here I start section say 1.1, and then you can go ahead and read 1.2, or just read my notes before you come. Just read my notes here. I'm going to put the notes here. I try to solve and try to, if you can figure out and just do it, you can do it. But for all cases, you need to purchase the access to my math lab, and from there you will see what's called you will see the textbook there, one section, and you can practice also for this one here. But when I'm going to give you the what's called the assignment here, you will see the assignment very much related to this one. But this week here we haven't very much given which chapter 1. So it's just we start section 1.1, just chapter 1. Yes. So it's kind of this week. It's almost very much enjoy your weekend here, and maybe from next week we'll try to you will have normal classes, and hopefully it will work here. Okay, guys.
Okay. All right. Thanks.
Sure. Okay. All right. Bye, guys.